YouTube's going. Restream is going. Concurrent viewers, 9. All right, let's have a welcome. Anybody in the chat? Can you hear me? I know it's not professional, but I have Kat. She's hiding from the cleaners behind my monitor. Right, girl? Kitty, kitty, kitty. Is everybody already on vacation? I feel like I missed the memo. Hey, Charles. Hey, Alvaro. Audio okay, levels okay. Thank you, thank you. Charles, can you hear me on YouTube? No beep beep. No, there's a... I think they're just painting across the street. I do have cleaners. We get cleaners in the house every month or so. So there might be some noise, although I think they did up here already. That's why the cat's hiding behind the monitor. Cat cam. Hi, Bruce. Hi, Jim. Sorry if the camera moves. It's because the cat is shaking the desk. You want to see her again? She's hiding underneath the monitor. We'll see what she does now that I'm starting to talk. She's just curling up. Yeah, Chad is behind. Ooh, Bruce says, as a Canadian, we were always on vacation. Marinating Korean chicken. That sounds delicious. I've got leftover Thai food to eat tonight. Yeah, sorry for the lag. As long as my video and audio is in sync, I'm gonna be pretty happy, actually. We'll see how the cat does. Hi, Ken. Hey, Charles. I think this is the only time she sleeps there, is when the cleaners are here. All right, let's get going. It's 2:01. She's gonna keep... I don't think she likes it. Hey, what are you doing? What are you doing? I can't kick you out. Can you hear her meow at me? She's upset that I'm talking. There's like a zip tie, I think, that she's playing with. All right, let's get going. I'm not that organized today, but you know, I'm never that organized. So let's do this. Hello everyone, my name is Scott. I work for Adafruit on CircuitPython. I do these streams every week to recap progress on the ESP32-S2. This is, I don't know what week it is. Lots of weeks at this point. I do this normally at 2 p.m. on Fridays. That is Pacific time because I'm in Seattle. So please adjust accordingly. I will skip Fridays occasionally when it is a holiday. In the US, it is a holiday tomorrow, and lots of people are taking today off. And I kind of like didn't think ahead enough to switch it. So here I am. And I'm glad you're all here with me. Let's see, housekeeping. Adafruit is shipping orders, so if you want to help pay for me and all the other people that Adafruit pays, please go to adafruit.com, purchase something there. You can get gift certificates anytime, and those don't expire, so you can use those in the future when a cool new product comes out as well. CircuitPython is Python for microcontrollers based on MicroPython, and we've geared it towards absolute beginners of programming to try to make it really easy for them to get going. Today, I'm going to do a recap of the spy bug that I spent 2 hours on last week and fixed in 20 minutes after the stream. and it's been merged in, which is exciting. And then we're going to start talking networking APIs. And the cat is upset. She's currently leaving. She's probably going to tip the garbage can over or something, but I think it's empty. And she was tearing up some paper that I pull up. Speaking of cats, I do have one other cat who's also sleeping down here. He doesn't fuss when I start talking, but he does have seizures from time to time. So if I ever do take a break and mute the audio and I'm looking around, just hang tight and I'll come back and it'll be good. Hi, Jose. Thanks for joining. Chicken and potato sounds good. If anybody's on Twitch, could you just drop a chat to make sure that the Twitch chat is showing up here too? That would be awesome. But yeah, I'm seeing Discord. I'm seeing YouTube. So thank you, everybody. So let's jump right in. I think that's all my housekeeping. Did I forget any housekeeping? Window's open, but it should be pretty quiet. So if noise starts, I will shut the window. So last week we were I was trying my darndest to finish up and get ready and do the PR for the bus IO support in the ESP32-S2, which is I2C, SPI, and UART. And I don't know, 4 weeks ago, we talked about the differences between those. And I started last week testing them and making sure everything worked. And I discovered that the input on SPI did not work, but it suspiciously looked like the input of looked like it was reading, the input it was reading was the output that it was also sending. And so, we agonized over making sure the two different muxes were set up and blah, blah, blah. And the half duplex setting was right. Well, turned out there was another setting called SIO. And thanks, Alvaro, for posting on Twitch. I see ya. So if we go, I don't think I pulled it up. Let's take a look at closed pull requests because it's been merged and there's some interesting stuff in that. So these are all the things that we're waiting for, but we also have closed pull requests. So if we look here, Spresent's got SDIO support, which is great. And I merged a number of these because I just released 6.0 Alpha 1. And here's bus IO. So let's take a look at that. I think she's looking for the paper she could tear up, but I moved it knowing this would happen. So if we just look at this commit here, which is titled fix SPI. Oh, you can't see. I'm sure you're all typing in the chat right now, and the lag has been so we'll catch up. It's all good. So there we go. So out of all the commits in the PR, I picked this fix SPI-RX and remove debug prints. And here you can see me removing debug prints, but there's this mysterious SIO setting that I turned to false. And, it's not labeled anything there, but I think I do have, if we just look here. That doesn't tell me anything either. Where was it? Oh, it was in this low level. Not there. SPI low level. Here we go. I even have it highlighted still. It says, set SPI to work in SIO mode or not. SIO is a mode which MOSI and MISO share a line. The device must work in half duplex mode. There you go. That was our problem. And so I turned that off and it started working, and it took me 20 minutes of watching Python T to figure it out. So it just is amazing to see how pretty quickly, like fresh mind, changing that can fix it. I think this SPI how fetch we fixed as well when we were experimenting on Friday. So the review was pretty quick, and it's been merged in, which is awesome. Jeff just pointed out a couple things that I feel like I should touch on because they're good points. One, I had added this thing to make one of each. So at the very top level of CircuitPython, you can say make one of each, and it will build one board per port to just do a broad sanity check that like every port kind of works. And then the other points that Jeff was making was talking about how I was saving some pointers. Well, I was passing pointers into the IDF, and then I was getting a handle back. And CircuitPython does this thing to try to reduce memory fragmentation, where after you do an import, we'll try to shuttle or move everything from that import off to one side, basically, that's compact. And that means that pointers can change. And usually the long-lived stuff works okay because like only the Python dictionaries have copies of those pointers, and we can update them there. But in the case where like some C code's like passing that pointer around, you may like the IDF may hold on to the pointer, and then we'll move it, and then things will be bad. So Jeff pointed a couple of cases where that was, and both cases that he pointed out, I didn't have to worry. Like one way to fix it is to just long live from the start, because then it won't move. Hi, Christopher. The other way to do it is like I just made sure that the IDF wasn't actually holding onto those pointers, and whenever I pass them in, so yeah, this timing configuration struct. What I did is I ended up just you pass it in via the HAL structure, and what I do is I just update it every time I'm about to do that. So I make sure that like if the object we are moved, like that pointer gets updated as well. So yeah, I did that there, and then for the lock, I actually looked at the FreeRTOS code, and the lock handle is really just the pointer being handed back. The reason that it changes is because like if you are relying on FreeRTOS to do the allocation for you, then you want to pay attention to the handle. So yeah, that's no worries. Yeah, so that is sorry, I got a notification and it just distracted me. So those are the two like memory issues that Jeff pointed out, but besides that, he didn't have a whole lot of feedback for the PR. So it's merged in. If you want to try it, I hope you have. And I am in the middle of getting 6.0 Alpha 1 released. It's on the GitHub page, but I think a lot of people took today off. So it's not actually, I don't think, merged into CircuitPython.org yet, because there were some issues with, so when we do a release, we have this JSON file for CircuitPython.org that has a list of all of the different downloads, that like files you can download, and we also have like download counts per board. So like on the big boards page, let me just show you. So like if we just go to circuitpython.org/downloads, like this page here where like there's a bunch of boards here, these boards are sorted by the number of downloads they get. And the reason I wanted to do that is because I wanted anyone who had any board that had CircuitPython support to be able to get to the top of the page. So you can see that there's a whole bunch of obscure stuff, and this one actually was just merged in, so this will get bumped up maybe. But basically, as boards get more popular, they should be at the top of the page here, and that's all done through download counts. But you can see here that 6.0 Alpha 1 is not released yet. But we have added this built-in modules available list. So it's kind of like bringing it more forwards what modules you can actually use per board, because it does change. Any questions? So yeah, if anybody can do that review, that would be awesome. I think most of the CircuitPython aces took the day off, which is totally understandable. Bruce says, I compiled it about an hour ago and haven't flashed anything yet. Yeah, cool. And it should be faster. I think I talked about this on last Friday, but between merging in Dave's fix for the sleep time being off for the ESP, and then also removing the delay, like the performance is much better. And let me tell you, Dave is awesome. Dave's been working with me this week to fix an issue with Pulsin on the SAMD21. So if you see Dave, say thank you, Dave Putz, because he's been doing awesome work. So yeah, that's my recap. Obviously, we're only 15 minutes in, but it really wasn't a whole lot of that. I guess I was going to say what I had to do is the way that the release process works is the website's got a JSON file that has all the boards and all the files for all the boards. And that file gets automatically updated by a Python script, and it uses the GitHub API to do it. But turns out with that, the list of all the modules supported by the board bumped the file size over a megabyte, and the API we were using on GitHub doesn't work for files over a megabyte, which is like, so I would have had everything released yesterday, but I hit the snag, and so I had to fix that earlier today. And the way that I fixed it is actually I just replaced, so when you spit JSON out with Python, you can tell it how many indentations, like how many spaces to indent stuff. And I just changed it to 1 from 4. So there's fewer spaces in the file, and now it's less than a megabyte again. But I also do have my mind is blanking. I had additional changes in there to add the languages for each release and the extensions for each board, so that we can actually remove, we have like full file URLs in there. And so now we'll be able to remove those in the future and get more space on back on that file as well. All right. Squashed it. All right, let's keep going. Oh, somebody's calling me. Potential spam. Okay. Let's talk networking. Is that okay with everybody? Seems like it's kind of a quiet day again here. But we get, it claims that we get like 1,000 views. I don't know how many people actually watch all 2 hours of the stream usually. So yeah, the next thing that I'm working on the ESP32 is networking. It is a Wi-Fi capable chip, and it would be nice to be able to use the Wi-Fi. So I was actually initially thinking I would be working on background task stuff, because I basically regressed how that worked with the low power work and made all of the Python code execution slower. But Jeff has an idea on how to do that, and so I'm going to hand it off to him instead, where he's going to keep doing it, which frees me up to do networking. Now, networking is a little complicated. Ken says yes. I don't know what the yes is in response to, but so one of the first things I did is as you know, I actually read the docs. I kind of like to take a look at the landscape and kind of like get all of the pieces in my brain so I can figure out what direction I want to go. There has been yes for networking. Nice. Sweet. So one thing I was looking at is this is the API for doing SSL communication with ESP IDF, and da, 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 comparison. So I think one thing that's going to come after networking is potentially dealing with memory, because obviously it can use a lot of memory to do that. So that's one thing that we're going to look at. And then I was just looking at like how it manages connections. So host name, host length, port, configuration stuff. And so this API is one of the things I was thinking about for network stuff. The other thing I was thinking about is that I really wanted to move Adafruit requests to a model where the objects it was taking were straight up like C Python objects. So one thing I've done is I've reworked requests, and that's not Python requests. It's like our version. It's Adafruit requests, and I've added examples here that use CPython socket, but use it with Adafruit requests. Now, let's just show that off. Too many tabs. I feel like, oh, yeah, for the election calendar stuff, I had to fix a homebrew formula. That's what all this US stuff is. I don't think we need that. We can do it in here. So I had this existing branch called HTTP 11, which is actually adding HTTP 1.1 support to Adafruit requests. And the reason that I wanted to do that is that I was hoping to make requests faster by leaving connections open and being able to do like multiple queries on the same domain. And so basically I took that and I made these two examples, HTTP or requests HTTPS CPython and advanced CPython, and I think simple test CPython as well. So we could just run that. Yeah. Oh, and there's this, it needs a Python path. So here we go. Fetching text. That's actually not working. It should be quick, I think. And I'm obviously on network because you can see me. So maybe the first thing we'll do is we'll fix this. But one of the main things that I found that I had to change is CPython. If you have a socket or if you use requests, you just import requests, because then requests can automatically or implicitly import socket. But in CircuitPython, like on the ESP32-S2, we're definitely going to have native networking. But in a lot of cases, our networking is actually implemented by a Python driver to an external chip. So the ESP32 is, as a coprocessor, is kind of like our canonical example of that, which is why you can see that it's open in my tabs here. So that's kind of where I'm going. But that's one of the... Oh, sorry. I must be like food coma from having lunch. So that is one of the things that really need to think about in terms of what is the API for like importing something and then kind of telling it like this is the implementation of socket that you should use. So right now I just have import requests, and then we set this top level variable in that module called socket module to our socket implementation. So one thing I'll have to do is like migrate this model like back into the ESP32 SPI stuff. I wonder if Wi-Fi test is down or something. It timed out. So that's one of the weird things that I have to think about with this. And then right now I think it's done through a function call, and the function call takes both a socket and an interface. Actually, I could pull up the current version of these examples to compare and contrast. So, no, this is the wrong library. Oh, that's the implementation. So for one, all of these requests examples, they use the coprocessor stuff. So there's a lot more boilerplate to get started with these examples. And that's one thing that's nice about the CPython examples that I've got is like it's 3 lines of boilerplate and then just straight into the requests stuff. So here you can see that this is giving the request module set socket and socket ESP, which is like they call it, the current code calls it the interface, which is like the Wi-Fi management stuff. And I really don't like that. I think that there's some room for improvement in terms of the boundaries of the APIs. So like requests itself shouldn't have to worry about like the reliability and reconnecting to the network. That should be all under the hood, and you should be able to maintain that and get like network status and stuff kind of separately through the interface instead. So I'm playing around with that, and I replace this set socket with just a straight up assign of an attribute. And then once I did that, I then ran this test with this example that uses CPython, and I was trying to use I wonder if it's down. Nope. So my code's wrong. Oh no, we're gonna have to debug this. I don't know why it's not working. So it timed out even though it shouldn't have timed out. I could just kill that. So the one API that ESP32 SPI's socket has that CPython doesn't have, which I found, and that requests uses, which I found pretty quickly by giving the CPython socket in place of the ESP32 SPI socket, was readline. And if we look at the initial version of requests, we can see that there's a few readline calls here. So this is in the request method, and we're calling readline, and then we're splitting it, into a status and a reason, and so I'm trying to think more about memory allocation, because ideally we can minimize the like peak memory usage for any one request by like never loading it all into one string. David says, I think I'm going to need to binge watch previous deep dive episodes. This is awesome stuff, Scott. Thanks, David. There's a lot of hours. I don't know how many we're at this point, but yeah, it's I'm glad you like it. We're gonna keep going. This is my life, just me talking about it. Mark says, miss me? I did. I was wondering where you were, Mark. I thought maybe you're busy, but I guess you're not in the US, so you wouldn't have a holiday. Mark says, I totally got tied up in sorting out my JLC order. It decided to miss something, so I've had to cancel it and add all 13 boards again. Oh no, that sounds rough. But I'm glad you figured it out. Side note, I signed up for WeChat last night. WeChat is an immensely popular chat and everything app in China. And if you've been following the pull requests that we've been getting in CircuitPython, we're getting more and more interest from getting more and more interest from Chinese engineers and Chinese companies with CircuitPython. So I started an issue and was saying like, what's like, usually I direct people to Discord, but it seems like Chinese, like mainland China doesn't have access to Discord. So I wanted to figure out a way that folks could ask me questions. So I joined WeChat, and the Seed Studio folks were super excited, and we have a group chat going. So if you are in China and you don't have the ability to like chat with CircuitPython folks, reach out to me. I'm Tannewt on WeChat, and we'll get you in that group for supporting Chinese engineers, which would be awesome. Thanks, Emma. Mark says, Emma said, you have a nice voice. Thank you. I appreciate that. Emmett asks, do you know the C language? And I would say, yes, I do. CircuitPython is written in C. I certainly don't know all of it, though. Okay, so that was a side tangent. Sorry about that. So with readline, what I found is that there was another place, and it does this very similar thing where it says, oh, I'm going to read line, and then I'm going to split on this character sequence. And what that's doing is like, it's putting the entire string in a buffer, and then you're immediately on the split, you're generating two smaller buffers on top of that and like throwing that memory away and churning through it really quickly. So I was thinking when I was redoing it, like, what if instead of having readline, which is not a socket API, what if we had a way to just read to kind of where we're going to split instead, and then just get that chunk in a single string? So what I've done, and apparently is not working, and that we'll have to debug, is I've added this read2, which you can see here. I've added this read2 method, private method, in not in socket, but in Adafruit requests, that you can basically say like read up until the point you would have split, and then read from there to the end of the line, sort of thing. So you have like two options. Read2 takes two things. It says, oh, okay, give me everything up to a semicolon or the new line. And I think, oh, I did. Perfect. And then also, let's see, it's complicated. And I'd like it not to be as complicated, but it's this trade-off between like, how much code, how much memory do we spend on the code itself versus to save the allocations that we're going to have on every request, every process. Hi, Johnny. Thanks for stopping by. So I decided to kind of skew that way of like a little bit more code that goes out of its way not to allocate is better. So there's a special case here. So basically the way I'm buffering is I'm no longer buffering in one giant buffer. What I'm doing is I'm like, because I don't know how long that line is. And if I just had one giant buffer, CircuitPython will tend to like double the size of the allocation every time. So if you have a 32-byte array and you run out of bytes, it will allocate a 64-byte array and then throw the 32-byte one away, like free it up. But if you have a really long line, the problem with that is that you try to allocate like, 1,000 bytes in a row, and that can get really tricky as your memory gets more and more fragmented. So what I did instead for this read2 stuff, and definitely adds complexity, but I have a list of 32-byte arrays. So the list itself could grow pretty big because it still has that property, but we're kind of like dividing that down by having like byte arrays under the hood for that. So that's what read2 is doing. So it's buffering the stuff that it's reading into these buffers, and these byte arrays. So these byte arrays it holds on to for the whole request, so they don't get allocated and freed super much. Although I guess they get freed after every response, so we could actually store those byte arrays longer term if we wanted. So yeah, here's the way that if we need a new one, I removed all my debug prints and now it's not working because I'm on stream. See, like nothing's happening. Like I thought I fixed it. What we could also try is that there's two other examples that I have going. Simple test HTTPS, which is also tricky. There we go. So that worked. Although maybe I commented out the... Yeah, interesting. So oh, you know, I think I commented that out because I don't know if... Yeah, I don't know if this Wi-Fi test domain actually serves up HTTPS. So that worked. And then does advanced work as well? Yeah, it looks like it does. Okay, so I think context-wise we're what, like 3 deep? So like the goal is to have Wi-Fi on the ESP32-S2, but as I do that, I want to have I want to take a look at like our broader networking APIs because I want to make them I want to improve our networking libraries so that one, we can use them with CPython sockets and CPython SSL, and two, I want them to use less peak memory, and I also want to use them use less memory as you import the libraries ideally as well, and I'll get into that. But first, let's dive deep a little bit here and just figure out why this isn't working. Why the simple test is broken. See, like that looks okay. All right. So let's just print out the arguments here. I am definitely planning on watching Hamilton tonight. Yeah. That looks okay. The other place I was doing it was after receive. Returning that. And receive into. So one thing I did is, I believe that the current ESP32 socket uses read to do read line. Yeah, so it's got a receive, but receive, like I'd prefer to use receive into because receive into allows you to reuse a byte array multiple times. Whereas if you're using the things that return bytes, you're like doing a lot of allocations that you're just gonna throw away. Yeah. Right, so here, like, it's good that they're doing this buffer thing, but when you're doing string concatenation, when you do a plus equals on a string, whether it's a byte string or regular string, like it literally takes the length of both of those things, does a new allocation, and copies everything over every time you do that, which is like it's not memory efficient and it's not CPU efficient either. So like it'd be much better to have a buffer that you just pass in and fill out. And then you don't have to do any new allocations at all. So I want to get rid of this read line in favor of the read to. But obviously it's not working. And we need to figure out why it's not working. So here. If you can read this, it's working. You know, that might be the end of the page. So that might be the problem, is that I don't know. Do I know? Johnny says strings are immutable in MicroPython. That is correct, I believe. Strings and byte strings are immutable. Yeah, that's right? Hello. 0 equals B. String object does not support item assignment. Yeah, so you can use byte arrays to allow you to do that instead. Okay, so that is interesting. Accept byte ranges, returning bytes. And then we're receiving receive. We shouldn't be in parse headers anymore. I don't think. I think we should be out of parse headers. And I think that's because parse headers should end if it's like there's two new lines, and that's when HTTP says like I'm done with my content. Actually, we could talk about HTTP. So if we see here, I'm opening a TCP socket. Yeah, that was the other thing I was thinking about talking today, actually, Johnny. Johnny says, okay, then I see there being lots of reallocations in my code. Yeah. I was actually debating adding a module to CircuitPython that would count the number of allocations since you cleared it. So you'd be able to say, like, starting now, count how many allocations I create, and like bin them based on like power of 2 size. So you count single block allocations, double block allocations, and then 3 and 4 as one, and then 5 through 8, that sort of thing. So get you kind of like a histogram of the number of allocations per block size. And a block is 16 bytes. So that's another thing to think about, is that if you're ever allocating something on the heap, it's going to be 16 bytes, even if it's shorter than 16 bytes. There are some exemptions to that, but that's generally the case. And that's true for strings for sure. Kind of. There are other weird string things. But in terms of HTTP, the first line is usually the status code. So what version of HTTP are we? What's the response code and the explanation of the response code? And then you get headers, and headers are a key, colon space, and then a value. So this is telling us like what server it is. This is what the date is. It's kind of hard to see here because we're reading it twice. So we're receiving it and then we're returning it. One thing that's really nice is you can get content length. If you don't get content length, then that means that you... oh, this isn't right. Like, this content length. Content length here is not correct. Huh. Oh, you know, wait, no. Yeah, that's not right. Oh no. I'm finding bugs. Actually, one thing I want to do that I think would be good, and I don't don't know when I'll do it, but I'd like to actually write some tests. Like, I think this library's only been tested with, the library's only been tested with this, these examples. It hasn't been tested, like, by injecting, like, values and things like that. So it would be good to actually have some tests. So let's figure out why this doesn't work. So this is definitely incorrect here. And the reason I'm printing out these receives is because it's kind of giving me an idea of what's like in my buffer. So let's figure out, like, this is telling us, okay, like, read to an RN. And, oh, this is what happened. Sorry, my wife texted me. Okay. So this is the problem, is that I am not handling the case where the value I wanted is coming at. So the trickiness with this thing of storing our buffered line in multiple byte arrays is that we have to be careful. Like, I'm looking for a particular sequence and then kind of keeping up to that sequence. But I can support 1 character and 2 character sequences, and that sequence might actually cross one of those 32 byte boundaries, which is annoying and adds complexity to this code. But again, it's still probably better to pay the cost of extra code than it is to like do one big string or one big kind of like buffer for allocations. Because if you can do it in a lot smaller buffers, you have a much better likelihood of being able to allocate over time. So this one's wrong for sure. And this is a bad one to be wrong, because content length basically tells us how much of the body of the HTTP response there is. So let's just figure that out. So what will happen is that we have content type, and the things I'm keeping track of are the length of each buffer. So if I have a 32 byte buffer and we say receive into this 32 byte array, I might not actually get 32 bytes. Whether I actually, whether it's because of, like, it's at the end of the response and like it just adds having like 32 bytes even stuff, or whether it's actually can be timing dependent as well. So with the SSL case, I actually found where it spits out headers, but then it has to like there's a delay for some reason. So I was getting like midway into the headers, and then it was giving me content with a new receive into. So I had to handle that, and that's handled with this buffer sizes. So that's like the end. And then the only way that the start of a buffer can be not at the start is the very first one, because we like already returned part of it and skipped part of it. So that's tracked with this start index. So that's keeping where to start in the first buffer. So if we're looking at content type, content type, we returned. We had to fetch this to get the E of content type. And now our start index, actually, we could just print it. Let's print it off. Let's make this clearer. And then we could even just print our buffers. So receive buffers. This is all like really like a good reason that it's nice to be able to test on CPython. Okay, so now we have some more information. And I'm lost. Okay, there's content type. Can you see that? I think I'm a little low. So here we're returning content type. Remember that any, like, there's there's two. So there's, at the start, there's 2 byte arrays, but then we're reading another one, which has replaced the second one. So when we return content type, we're picking content type from, don't do that. We're picking content type from here, and then the first E of the second byte array. And then when we're done with that, the last buffer we're using, we put in the first position because we're going to start with that next time. So that's what this has done. So we snagged this E, and now we do a find for the RN that we're looking for. And we're starting at position 3. So we start here and we're looking for the RN. So the other thing about using find that is nice is that it's implemented natively. So I don't have to do any sort of like iteration or comparison in Python. It's in C that's going to be doing that for me, which is awesome. And actually, I'm not positive we have it on CircuitPython. So we might actually have to add it, but it's worth it, I think. So that's how we get text HTML. And now our start position should be here. And we search again for either a colon space or an RN. And we go here and we find the colon space. So we return content length. And now we're here and we do the 70, but we didn't find it in these first 2. So now we have to fetch a new second buffer. That's what this is. And now we find it, but find of that second buffer is going to be 0, and we're returning the wrong thing in that case. So let's figure out. So this is wrong. I broke this when I handled the case where it's across the 2. Or no, that should be right still. So this is the loop that's like fetching another buffer and looking for stuff, causing the receive. And our current buffer is going to be 1. So let's just print current buffer, which would be 1, and found. Let's see what we got. I'm going to have to find it again. So content length. And yep, and we get a 1 for buffer 1 and starting at 0. So let's just walk through that here and see how this works. So this is programming for you. This is you know this is what my show is. This what this stream is all about, of like getting in the weeds of programming. So one thing I could do, no, I can't do that. But basically, if buffer is 0, start at index is greater than 0, copy it in. So we do get it. We do successfully snag it. This new length is not right though. Let's move this down 1 and see what new length is, because it really should be just 2, right? Like it. Hi Kitesh. What are we trying to do today? I'm working on a library that's modeled after requests, trying to make it more memory efficient and inform how I'm going to organize new Wi-Fi APIs for the ESP32-S2 chip. If I had to summarize, I think that's what I'm doing. So content type, content length. New length is 2, which is right. Byte array. Why is it getting longer? We must be accidentally extending it here? Oh, that looks right. I think for let's do print buff I. It's not the ESP8266. It's like kind of 2 generations after that, the ESP32S2. But yeah, that family for sure. Right now I'm just doing working on the Adafruit request library with CPython though. I'm not actually on that chip. So this is kind of cool. So here we can see that we're correct at the start and then we're adding more when we shouldn't. So if it's like found is greater than 0, do this. Oh, we're hitting this case. What? Oh. My neighbor sent me a text of a raccoon outside. Okay, so I think this is what we need to do. This is the case we're in where buff I is current buffer. But because found is 0, we're actually falling into this last case, which is actually, like, if you think about it in terms of, like, what if we had 3 buffers that we're copying from, right? The first buffer, we're going to start somewhere in the middle, and we're going to go to the end. That's the first case. And then the last case, we're going to start at the start and go for a while. We're going to go till we've found the sequence we're looking for. But that's 0 in this case. The middle case, we just take the whole buffer. And so because found is 0, we're accidentally taking the whole buffer. What we need to do here is we need to say, I mean, we could call it, but I think it'll be a no-op if we add like I to I equals buff from like colon to 0. Like that's gonna matter. And beware, like when we're talking allocations, this actually does cause an allocation, which is unfortunate, but it's a small one where if you're doing a slice of a buffer, it's gonna like it's gonna create another version of the buffer, and then we're immediately assigning it back to the big one. So it's kind of unfortunate, but my goal is definitely a raccoon, I think. My neighbor asked if it was a possum. I don't know if you can. Yeah, it says raccoon. Can you see the raccoon? Updates from my neighborhood. Okay, so I think this will fix it. Basically, we always end up in this case. We won't go to this else, and we'll only actually copy it over if found is greater than 0. So let's try it again. And that looks better. Yeah, so content length, 70, last modified, date and time, connection, keep alive, Jtag, this, accept ranges. So this is kind of interesting, is that all these zeros are like we created the byte array, but we haven't filled the full thing in yet. Kind of neat. Accept ranges, bytes. And now we're getting down to the bottom, and we're not like, I think we're still in parse headers, and like we're not correctly kind of kicking out of that loop to parse all the headers. So let's take a look at that. Gitasha asks, wanted to ask, where do you manufacture your IC? Like technically the integrated circuits that we have on there, we don't manufacture. Like ESP32 sort of thing, like we don't manufacture that, but the circuit board, the printed circuit board assemblies that Adafruit does are assembled either in New York City or in China with a partner factory there. Hello. All right, so let's take a look at this. So we got bytes, and then we're getting 2 empty things. So I think what we should return is we should actually return an empty. So let's figure out why. Where in this case, we're starting at 19, which is probably here. We're not returning empty. So what I want to print out is, it's like raise your hand if you like printf debugging. Definitely me. So this is true. So we are in this case where our start index is in the first buffer that we've already picked. So let's print first. It shouldn't actually be first, because first is the colon that we're looking for. And then second. It's kind of gross, and I was like trying to figure out how to like structure this better. So if you have ideas, let me know. Johnny says print for the win. Totally. Printf debugging is like, it's the style of debugging that works whatever system you're using. That's why I like it. Is like, yeah, it's weird, but it's like the first thing you learn when you learn a new system is usually how to print stuff out. So like, you can always printf debug no matter what. Like, although I take that back. There's been 1 or 2 times I haven't been able to printf debug, and that was like debugging embedded startup issues, and that was like, I ended up like doing like LED blinking to figure out like how far into the script it got. Okay, well, second I is greater than 0. We should say found. Although first is not strictly less than 1. That's not right. It is 1. Nice. At least it's cheaper. It is true. That is definitely true. Heyo, it worked. All right. We fixed it. Thanks all for joining into that fixing party. I'm going to delete all these prints, or at least some of these prints, to make it clearer that I fixed it. Johnny's on vacation time too. Yeah, like, I chatted with my wife and she's like, yeah, I'm taking 5 days and I'm to hang out with my family at the lake in the sun. And I'm just like, maybe I should rethink my weekend plans and actually like not work. But I had already committed to doing this. I had cleaners coming. Monday I'm running the meeting. So I am going to my parents' house tomorrow for the day, which will be fun. And I'm definitely watching Hamilton tonight because I listened to that a ton. And they just released the like videoed version of the Broadway show. So I'm pretty excited because I haven't been able to actually see it in person. Okay, so this works now, which is awesome. Let's double check that the other two work. And go hiking. Yeah, that's a good idea. My wife loves to hike though, so she's gone till Wednesday, and then I think once she's back, we'll do that. Plus, like the weather here in Seattle, it's like super stereotypical, but like there's a saying that summer doesn't start until after the 4th of July, which is this weekend, and so it's like 65 out. It's like not very nice out. So yeah, it's actually like it's a long weekend usually, but it's never usually that nice. So it's okay kind of holding off and doing hiking later, I think. Although it's beautiful here year round as well. Okay, this all works, which is awesome. Cold and rainy. Bruce, you're in Vancouver? Yeah, I think that's right. Mark asks, have you ever used Jtag with the ESP32? I do like printf debugging, but sometimes it's really good to use GDB. I haven't yet. In my Sala Feather adapter, I did put a Jtag port, but I have not tried to hook it up yet. I think that's something I'd like to do at some point, but not today. All right, so we're about halfway in the stream. We fixed something, which is awesome. In fact, I'm going to commit it. Nice. It snowed at Whistler. Where's the socket wrapped? We can get rid of that. Don't need that. So, one thing I want to ask is, let's look at this other example. I want your feedback on this. So is it weird, or is it too weird, where you import a module and then you have to immediately set to I like printf debugging because I know how to do it on every platform by default. That's why I like it. And I don't need some editor that I've set up in exactly the right way and things. I'm weird. I'm only in my 30s and I already feel like I'm kind of like curmudgeonly in my process. Is it worth using Jtag for ESP when we have IDE inbuilt debugging option available? Yeah, I don't know much about how that works. Jtag, I've done a lot of ARM, and with ARM, GDB is really nice because you can straight up stop the CPU, and have full access kind of around it. It also means that USB is not going. So when I'm debugging USB connections, I love to debug with GDB because I can't have my USB active because it's broken. So there's definitely a place for it. Johnny says, just wait till you pass 40 then. I know, I did this I think it was this week. I did this talk we have some fellows that we're working with. And they had this Q&A for me that I did. Was it yesterday or the last week? Anyway, it was funny because they were asking me how to build a name for yourself and things. And I'm like, that's not what the tech industry is about. Get your resume up to snuff and you won't have a problem. Build your network out for sure. Okay. All right, let's commit this. And I'll push this up too right now. Switch to read to from readline. Git push canute HTTP 11. All right, so that's up there. The problem with this is like we have a number of libraries that use this now, and so I've got to go update all of those as well, or at least do enough to know what I need done, and then I can recruit Brent to help me out with it. So I'm happy with this. I'm happy with Adafruit requests. Now calls read to. It doesn't use read line. Now let's take a look at. Sorry, did I say I'm not actually gonna? I'm not planning on getting to the ESP32-S2 today, and I'll tell you why. Because I want to figure out what the APIs are. So like, figuring this out is really helpful because then I'm gonna I'm thinking about what the native shared bindings API for a native accessible network will be. And I think socket's the right approach, and we're gonna also need this SSL layer that has this context wrapping thing. So I'm thinking about that. And then I'm also thinking about, or I need to figure out, and this is what we're going to do next, is figure out what the API for managing the connection will be. So we'll basically, I think, kind of where I'm going is the ESP32-S2 API, networking API, is going to be actually the generic Wi-Fi networking kind of sets of APIs that people can then implement under the hood. And that'll be, I think, I'll probably call it just Wi-Fi. So you could say import Wi-Fi, and that's where you do your scans, you manage your connection, all that stuff. And then from there, you'll be able to say Wi-Fi.socket or something to get the socket implementation that you would set here. And then you would also get an SSL implementation that you could create these default contexts and stuff with as well. Because with SSL, you need to manage what certificates and things you have. So I think kind of straight up just copy that from CPython will be good. Or at least not the whole thing, right? We never really copy the whole thing, but we'll copy a subset depending on what we're able to do now and what people want to do in the future. So I was talking about memory use, and the thing that I have going here is, one, my ESP is not happy, and I don't know why. But two, I'm also printing out how much memory is taken up by the 3 imports at the top of this example. So this is the example I have. It's pretty basic. Yeah, this is just the ESP32 SPI simple test, and we're gonna have to figure out why it's not working. But actually, let me move this off. I had the cat up here, but the cat bed doesn't need to be there still. Okay, so what I added here is memory issues come up a lot. And I did kind of a deep dive years ago, 2 years ago, more, when I wasn't doing them regularly. I did this long couple of hours talking about the heap visualization stuff that I had done and how to debug what's happening on the heap. And the first basic tool that I would point people to, and that we point people to, is this GC mem free. And what this is doing is it gives you a coarse idea of how much memory has been allocated from one point to another. And that's helpful for reducing the memory usage of something. That's not perfect. And it's not perfect in terms of I got a memory error, but there's a lot of memory free. And that's because this metric doesn't really account for how fragmented it is. So it's only really good to know differences between what you allocated. So let's just, I gotta save it. So I want to just see, so there's 3 imports that I'm interested in. Johnny says, yeah, the deep dives, those deep dives gave me a headache. Yeah, those are really deep dives. Those are multiple atmospheres of pressure deep dives. You got the bends from a deep dive. That's what you did. But yeah, I think it's super fascinating. I'd never really thought about it. And memory allocation with CircuitPython, memory allocation itself is something that's been studied a lot, but the study of memory allocation, I think, has really kind of grown into like large memory spaces and complex operating systems. Like I haven't been able to find a lot of details about like constrained system memory stuff. Yeah, somebody's doing brush up on those old deep dives. I don't even know if they're on the playlist. They might be. But those I think they're still relevant. Nothing's changed since I did that work. Well, nothing really on the way we allocate. But it can be really interesting. And I'm seeing more and more people be like, hey, I'm using the SAMD51 and I'm still running out of memory. Like, for a while, it was like, oh, it's so much memory, we don't have to worry about it. Like, it's way more than 32K, we'll never hit it, but like, people are hitting it. And I think if we learned anything from Bill Gates's quote, like, we're never going to have enough memory. Like, can we all just agree that we're never going to have enough memory? Like, we're always going to have memory issues? Like, that's just always going to be the case. Like, even once we get the 2 megabyte SRAM on here going, like, we're never going to have enough memory. So then the question is, if you never have enough memory, what tools can you provide to make people more aware of the memory that they're using? Like Johnny was talking about the fact that like, oh, I can see I'm doing all these, knowing that strings are always copied and moved into each other, like that they're immutable. Like I understand that I'm doing a lot more allocations than I thought it was. Like, so the question is like, what do we need to teach people so that they are more aware of the memory impacts that they're having? That's really interesting. Kind of, I think there's a lot of work there we can do, and it's an interesting thing to think about. So yeah, what I'm doing here. A slice of already allocated buffers. Microsoft recently revisited the subject of memory allocations in .NET, and the result, they invented span. A slice of already allocated buffers. Is that multiple buffers or a single buffer? Because MicroPython and CPython have memory view. So if you have a big byte array and you want to operate on just a portion of it, you can do a memory view, but that still allocates the memory view object. It just points to the same buffer. Which I actually, in those cases where I'm doing slices, is probably a better idea. But I'm slicing on a small amount. Yeah, it's all small objects. Like it's the large objects that I'm worried about, because those are the things like we usually have plenty of memory. It's just fragmented. So if we're allocating small objects, we're more likely to be able to allocate it. Anyway, so what I wanted to do as a sanity check here is there's 3 imports at the top of this simple test file. There's socket, there's ESP32 SPI, and there's requests. And I want to just measure how memory changes from after one import to the next. So what I've got is I've got a start GC mem free. I've got one after socket, and now I'm printing off the difference. I've got one after I import ESP32 SPI, and then I print the difference. And lastly, I'm working on this requests one, which I'm going to do the same thing. Sounds a bit like memory view, yes. Warning, unexpected maker. Brain capacity is at 0% today, so going to try to follow along, but it's unlikely. Hey, Sion. If you do have any brain power, the unexpected maker Feather S2's now, well, soon to be on circuitpython.org downloads, because I added it with the bus.io thing, I think. So we're going to have to make a page for it. Get some pictures. So after requests minus after 32 SPI. I'm definitely like, oh, one of these is backwards. This second one is backwards. Wow, that's giant. Right, so the number's going down as we import more stuff. Okay, so socket is 2800 bytes. ESP32 SPI is 17 kilobytes. And requests is 1500 kilobytes. Which one of those do you think is a problem? So people, let's see. This has come up recently on the IMX RT1010, which I currently have configured to only have 64K of heap space. So if you're doing this 17K, like you're using a large chunk of it just for ESP32 SPI. Bruce says, "Yep, that board's in the poll." Yeah, and we got the Seed Studio folks, and they're doing the Wio terminal as well, which is neat. That's in there, and then I pointed out to them that they could like initialize the display by default, and they got really excited. So it looks pretty cool, and it's like $30, which I was surprised by. I need to order one. $30 for a SAMD51 with a like, nice enclosure and display. It's pretty neat. Okay, so I want to make this number go down. That's what I want to do. I want to make this number go down. And I was looking at this file, and the reason that I want to look at this file, let me talk about this as well. Like, so there's three APIs I'm thinking about. There's socket, which is going to be just CPython socket, a restricted set that basically Adafruit requests uses. There's going to be a second API for SSL, which is going to be CPython's SSL, where you can create a context and you can modify it and stuff. And then the third API is the one that's kind of like doesn't have a good corollary in CPython, which is like how do you manage a Wi-Fi network, which we already have with this ESP32 SPI class. But the problem is that it's giant, and I don't like that. And let's look through it and see what we can do to make it smaller. And I think the reason that it's giant, so here's the file. I think that the reason that it's giant is that the when it was created, basically everything was added to this one file, and I think that might have been because it was inspired by the Arduino library. And like, remember Arduino has this property of like, if you don't use something, it doesn't need to include it, like, because it has a compiler. Whereas with CircuitPython, like the boundary at which things are imported is usually the file themselves. David says, "Oh no, he said the magic word display. I have to check this out." Yeah, it looks like a neat thing, and they have a lot, but they're all in the Chinese warehouse. I've got the link here. I'll post it. It's like, the display is like not that interesting to me. The fact that it's in a nice case is pretty cool though. It does have Wi-Fi and Bluetooth, but be warned, it's not supported. But it is something I'm thinking about when I'm talking about these three APIs that we put in shared bindings. Like, theoretically, that's something that we could implement natively and then expose through the same API with a just different coprocessor. Or, yeah, with a different coprocessor. That's the right way to say it. And those three APIs need to be provided by both Python and C APIs, right? So like this ESP32 SPI library, we want to be able to implement those three things in Python completely without C. Okay, so let's take a look at this. These are a bunch of defines. The ones that start with underscore should be basically inlined and not cost too much space. But for these, for example, where they have no leading underscore, meaning they're public, the name itself, so if you're thinking how much memory am I using, this const 4 is just going to be a 4. That's going to be 4 bytes. That's going to be 4 bytes. It's going to be a word. It's not going to be a separate object. But then there's also this, and this is a string. And we keep these strings because you might reference them. We do deduplicate those strings, but we do keep them. So if you're looking at a module and wondering where memory is going, one place it can go is actually the variable names. which is kind of wild. And they're deduplicated. So let's take a look at this. And in fact, there's this pilot, too many public methods, too many instance attributes. So let's take a look here. We're going to definitely want this bit. This is the bit that's actually like setting up the connection. We're going to want that. We're probably going to want to be able to reset. We're going to want to wait for it to be ready. And then there's this send command, which you probably want. Read bytes, wait for SPI character, check data, wait response command. Okay, like we're halfway through the file. Send command, get response. But then we have status, firmware version, MAC address. Again, seems pretty reasonable. Starting a scan, get scan. Okay. Scan networks, which calls start scan and get scan. Which I think I want to redo this. One thing that we do in the BLE APIs is if you do like an advertising scan, we actually will, because Python can do generators and like return things as it gets them. I'd love the scanning API to actually be a generator instead. You're welcome, David. And again, sorry for the noise. There's construction outside. Set network, set pat phrase, enterprise ID, enterprise username. And these are all wrappers around this send command get response. So the function name takes memory, the function body takes memory, the runtime errors take memory. But this all still seems like related to managing Wi-Fi, which is good. I don't know what this is. Is connected. AP listening. Connect AP. Using secrets. Like, this seems a little weird to me. Like, there's no reason that we need this separate, like, pass in a dictionary sort of thing. Create an access point. I think that, you know, we could probably split this into two, where like connecting to a Wi-Fi access point and the stuff around that is one object, and like creating an access point that people can connect to is a separate thing. Basically, I think what we're going to want to do is take this file and split it apart into a lot more smaller files so that you can import just the things you actually need. And that'll reduce the 17K. We probably don't need this to pretty print IPs, or we could construct another object that can do that as well. Convert a host name to a packet 4-byte IP address, pinging, and then so like these are not necessarily things that we need in this object. We can make them in like a helpers or a like other sort of thing where you just give it and it does it for you. Like these are kind of like convenience things. And in fact, we could see like how Python does ping. I bet they have it. But so we're at line 615. We're like 2/3 of the way through the file, and now we're doing get socket, socket open, socket status, socket connected, socket write, socket available, socket read, socket connect, socket close. And you might start to think like, wait, I thought we imported socket. Well, socket is here. And if we look, we're going to delete read line. Oop, and I missed these things. Oh, sorry. Hope it wasn't turned up too loud. So here we're calling socket provider socket connect. And I think what we want to do is we actually want to take socket connect and just put it here. And we're going to have to make that, let's see, if we're looking at socket connect explicitly. Like, okay, socket open, which should be... So for UDP, we're going to have to figure out how CPython does UDP, because I have a feeling this is not how you do it. But basically, we can delete socket connect if we're able to call, yeah, like these. There's other socket things here, but we can move those too. Basically, like the logic is split for socket between this class and the socket class, when it should really be moved all the like completely over to socket, so that if somebody's not using socket, they don't import it, they don't use it. But I think what we're going to have to do is then make this send command get response, which is used pretty commonly. We'll just make that public and document it. It's fine. We can do that. Like maybe there's an argument that we need to like keep these commands private, but we can move these commands into the socket thing instead as well. So server, ESP debug, which probably don't want to call it that, but we can still have it. Like, I think a lot of these names, these are Arduino names. Like, it feels like that to me. And now we have pin mode, digital write, analog write, digital read, or set digital read. That doesn't make any sense. Like, this should be get. Get time, set certificate. So this is SSL related. Private key. Yeah, and then Yanni points out that we also have Wi-Fi Manager. So I haven't even looked at Wi-Fi Manager. Let's look at Wi-Fi Manager. I haven't looked recently. So with Wi-Fi Manager, yeah, so we're passing in secrets. We have a status NeoPixel. So this is like higher level, like keep me posted on the health of the Wi-Fi. Connect normal. Like this should probably be underscore if we're only gonna expect people to do connect. Create access point, connect enterprise. So this I definitely do not like. Like there's no reason that Wi-Fi Manager should be used like requests. The only reason that's there is that it's doing this like a connection check and trying to reconnect once you call it. But there's no reason to do that because the request is going to call out to, I mean, we're going to lose this pixel status stuff. But we're like socket should handle the fact that like we're not connected to the Wi-Fi. If we're trying to connect, if we called connect on socket, like we should connect to the Wi-Fi if we're not connected already. So like there's this weird like split of responsibilities, like where things should be. And there's ping again, and there's IP address, and yeah. So Wi-Fi Manager is like trying, and this is a question we had with the BLE stuff too, is like how do you manage a connection that comes and goes? Like do you do it at this very top level or do you do it like underneath? And I think at least for this Wi-Fi stuff, like the socket that ESP32-S2 provide, or that the ESP32 SPI library provides, like should know that like, hey, here's the ESP32 SPI object I'm talking to. You're calling connect on me, but like let me double check and make sure that we're connected before we do that. And that, in fact, let's just look. Does that do that? No. So I think the problem is that I think originally when this socket stuff was connected is that it was trying to be agnostic to the thing that provided the socket, which is not what I would do now. This is bothering me. Let me fix this. So one thing I've already done is I plumbed some more timeout stuff through. Oh yeah. And this socket provider thing we don't need. And this set interface. again, we have this problem of like, how do we manage this? Like, I really want to pass a module around, but don't want to pass a module around. Maybe it shouldn't be a module, but maybe that's the thing. It was like, just because, like, yeah, it's tricky because CPython doesn't have this paradigm. Like, CPython has an OS underneath it that manages all the network stuff. Whereas in CircuitPython, we don't. So that's the tricky bit. So yeah, I think what we're going to want to do is, the problem with this socket is that it was originally designed to work with any sort of socket provider. Whereas I think what's happened, and let me double check. So let's just look at another kind of peer library of ESP32 SPI. And I think that would be like a Fona cellular module. So let's look at this. Adafruit CircuitPython Fona. And now we have a socket here again. So, but let's start here first. So, okay, this is going to be the equivalent to like our ESP32 SPI thing, right? So it's initializing stuff, factory reset, getting IPs. That all makes sense. Although this is GPRS. Oh, that's data, I think. So yeah, we want that. Signal strength, GPS. So maybe like GPS, maybe that's not something we should have here. Again, we have a copy of the pretty IP libraries, which is unfortunate. And then we have SMS stuff as well. So like this SMS stuff, I mean, it's sectioned out here, but we really shouldn't have it on this object, I don't think. Because like if you're not using SMS, if you're only using it for data, like you're only using sockets, like you should use socket or you should use an SMS class instead. And what we see here is that these socket connects and stuff, I think they're going to be the same API before. But then there's also this Adafruit Phono socket, set interface. It looks like it's a lot shorter, but it's like calling to this interface notion again. So like it's been propagated over there as well. The main thing that we have here is receive again. So we have that buffer plus equals happens here as well, which it shouldn't. Like ideally, anywhere we have receive or it's something that returns a bytes object, we should get rid of. Like these APIs really shouldn't need that, because if this is the API that's underneath Adafruit requests, and now if I make Adafruit requests be read into, like then everything below that could just be reading into that buffer. The one thing to think about is that like there is a world where you may actually want to read more than what you need based on the user code, and that's the world where you're getting huge requests, or the device, like your coprocessor, doesn't have a large buffer, and you basically need to slurp it off as fast as you can. You may want to actually have your buffers be larger in that case, so that you don't run out of space on the coprocessor. And here's readline again. Yeah. So we have the same problem here. So I'm going to start with ESP32 SPI and kind of just like, I don't know, have I been on this thing where I just kind of like, I've got 20 minutes left of the stream or so. I think I think of it kind of as just like a toss it all up, put everything else where I want it, and then fix it all, and go do that. So I think let's just like go heads down and do that. fix this because it's bothering me. Yeah, and I think Becca and I, my wife and I, were talking about like, how do you learn? Like, how do you get an intuition for like recognizing that like the socket implementation is split across two things that it really shouldn't be? And that's a great question. I think that the answer is experience, and it's not programming experience necessarily. It's what really feels like software engineering experience to me. Uh-oh. YouTube says I'm losing bitrate. Let me know if I drop off. OBS looks green, so it shouldn't be a problem. Okay. Request is set. Let's do the easy ones first. So PWM out, how does that work? Is deinitted. ESP32. So it takes in ESP. What? Does this work? Where is the underscore ESP used? Oh, there it is. Oh, analog right. Thanks, Professor. YouTube looks okay. Yeah, it's warning me. I don't know why. Johnny says the rule of single responsibility. Yeah, but I think the thing that is confusing about this is whether you like there's a bunch of those constants, right? Like there's a bunch of constants at the top of this file, and the question is who's responsible for knowing all these commands? I think that's the reason that it's structured like this, is that like trying to isolate these commands to this file rather than like for the work that I'm talking about doing, I'm going to scatter these commands throughout multiple files in this module instead. So I think that it's like not as clear cut as I'm maybe making it seem. So yeah. So the analog stuff, and that's totally like setting analog values and calling it PWM is like classic Arduino. Like very clearly came from Arduino that's what happened, which is just not something I wanted to do in CircuitPython, because like on most of the chips we run on CircuitPython, like analog means an analog to digital or a digital to analog converter, which is like better than PWM. Okay. Private key certificates. We're gonna make that. We'll do an SSL module of some sort as well to manage the certificate stuff. Analog read. But it's set. Do you think it's even used? It kind of feels like it wouldn't be used. If you want to bug me about the fact that I use printf debugging, you can also bug me about the fact that I do just like grep to find things. Okay, so it's in examples. The attenuation of the analog read. What? All right, I'm not going to do that. Yeah, let's not dog on it too much. If you don't like it, let's change it. Let's make it better. I don't want to insult the people that got it working and got it running. Set digital read. Well, we have a digital I/O, and it doesn't use it. Does it only do one direction? I think, if I remember right, when this library was coming, or when it was created, I pushed for this API because by having this API, you can then drop it in where a digital I/O is also used. But it looks like the input side never got used. API pin handling. Huh. Interesting. Switch to output. Pin value. Yeah, Charles, this is the code for the ESP32 coprocessor. Yeah, and the reason I'm looking at it is that all of these things, like the ESP32 SPI and the FONA, like they're all the same thing in terms of like they're a coprocessor that provides network and some other stuff. And the reason I want to work on that is because I want the new networking APIs that I introduced with the ESP32-S2 to match the coprocessor APIs. So basically, like, there's no special treatment of whether the chip that you're on is actually a Wi-Fi thing. Like, you would treat the fact that the ESP32-S2 does Wi-Fi in the same way that you would treat the external ESP32 SPI Wi-Fi and the phone Wi-Fi and all that stuff. Okay, so I'm gonna move that as well. So value here, I'm gonna get rid of. Because I wanna match, I wanna do a better job at matching the way that that it works with CircuitPython itself. So like the responsibility of the digital IOs to know how to set it true and false. It's like the pin is just like a reference. It's not like smart on its own. And this is a MicroPythonism. I don't think that's where they got it. I don't know where they got it. But it's a MicroPythonism to say, if the value you give me is not none, then it's a set. Otherwise, it's a get. Like MicroPython does that. And the reason MicroPython does that is they do it because it's one less level of indirection when doing the action. Because you're like going straight to the function call. Whereas if you have a property, you have to find the property object, look at the function pointer for read, write, or delete, and then call that function. So there's like a little bit extra work and it slows it down. And finding properties is not super easy. So there's like some work there too. But I think the API is much better for properties. Okay, so we're in setter. We're given a value. We're going to say self value low and high. So I assume we're going to want to store it. And then we're going to want this. So we'll do argument checking. But we don't want to actually call set digital right either. Like, let's move that here as well. And I'll have to update the examples. So we don't need the second call. Invalid value for pin doesn't make sense, although maybe I'll run into it later. And digital read is separate as well. So some from here, set digital write. Let's remove that and do this. Pin ID. Here's another allocation that people may not recognize. So wrapping something in a tuple. So this is an allocation of the tuple object itself, and then setting the value to the thing that you pass in. This is also another tuple allocation. I think I'm kind of ruined when it comes to doing Python stuff. I'm like, oh, I see allocations everywhere because like Python itself, like they don't really want you to worry about it. Okay, and then this set command get response is like pretty common, so I'm actually gonna delete the underscore from that. And this goes back to my, like what I was saying, my approach is really like toss everything up in the air and then figure it out afterwards. So it's not gonna work after this. I hate to break it to you. Okay, so now we have a setter that's calling this set command get response. And I think I did see set analog read. Like this is a digital read command. So let's just ignore the fact that it's spelled wrong, or that there's a typo, and implement that as well. And this is a thing. So this is a value as a property. So documenting it as returns is not correct. You have to think about the way that you read the docs from the outside, not from the inside as we are right here. Okay, so delete this. Returns the Boolean value. So we do want to do a firmware check. That makes total sense. And I know I forgot to, we need to do this on ESP. And this should be private. So verify the firmware. And we're decoding it. All right, well that'll work until it won't work. That's basically getting the third character. And it's an assert. Do we want to do it as an assert? We can leave it for now. Response is not Boolean. Okay. Here's another allocation. Set digital read and write commands. Let's move those over too. We could leave them in here, but then they would be we're going to need 3 of the 4 of these. I don't think we need analog right. But I think we're going to need pin mode here shortly. So get response digital read pin. Okay, I think that's right. I think that'll work. Set direction. So this is we're doing a pin initialization, which doesn't make sense. Well, it makes, The pin object should be dumb. Like there's no reason that we need it. Like it's doing some abstractions for us that we don't actually need. So pin mode, in, out, low, high. Defaults to in, which makes sense. So I think one thing we will want to do actually is make it like an equivalent of the microcontroller file that has a pin object for everything, and then we can just make sure that the object that digital I/O is passed in is a proper pin. That probably didn't make sense. So input is default. And that 0 is kind of annoying. Oh, you know what? We don't want to do this either. I think what we're going to want to do is we're going to use push-pull open drain of digital I/O directly instead. We don't need to redefine it. We can just use it from the built-in. And on Raspberry Pi, we have digital I/O equivalents as well. So this will depend on digital I/O, which I guess could be confusing. Which is okay. We can figure that out. Okay, so we're gonna set it to input, and let's pull in set pin mode. Set pin mode. Command. Okay. So here, like we have some response checking again that maybe we should factor out. Interesting that it takes output and input as well as 0 and 1. I'm going to delete these because we don't need them. Oh, look. In, out, and let's put these with these. Pin mode in and pin mode out. And so because they start with underscore and they're const, they should, the names themselves should not make it into the like MPY file. Okay, so we're gonna do switch to input, and I think I'll just duplicate this. Well, no, I have direction. But direction usually calls switch to input. So let's do this. Let's just have it twice. Pin mode. Sorry. Any questions? I'm almost running up against my time, but I'm kind of in the zone. There's a lot of this work to do. Hi, Ali. What is this for? It's this is a deep dive. I'm Scott. I work for Adafruit, and I basically stream me programming in the weeds every Friday at 2. What I'm working on right now is I'm reorganizing the ESP32 SPI library, which is used to provide networking from a separate ESP chip alongside another chip, like a SAMD that doesn't have Wi-Fi. So I'm reorganizing it to try to balance where the code size is impacted. So like where the logic is across a number of files instead of one central file, in order to make the one file that you always have to need less large or smaller, less large, also known as smaller. All right. So let's import, let's say from digital IO import pull. We only really need direction, I think. Import direction. So we just say library refactors are always nice. Yep, that's exactly what I'm doing, is trying to refactor this library. And I'm doing, the reason I'm doing it now is because I'm planning on adding Wi-Fi support to the ESP32-S2, and I've got to figure out what exact APIs I want to work towards there. And so, yeah, I'm refactoring this library as a way to figure out what the APIs I'll add for the ESP32-S2 are. Okay, so for direction setting, I'm just going to say new direction or direction is, it's actually a digital AO direction. And this is just going to be switched to output. And switch to output takes, it has default values, so I don't even need that. It says, I miss Python. I wrote it in it for 5 to 6 years, from embedded system stuff to full stack stuff. Been writing in TypeScript. I do like typing. I think I want to get to the point where my Python has more types. Not there yet, but it would be good. So I'm actually going to get rid of these 3 things, and I'm just going to call switch to input, and switch to input is going to set, I guess, you know, Pylint likes to have direction. So this is actually we'll call switch to input, because this is an assign. But I think that we do want to hold on to the pin. This is going to be so broken. Wait, set pin mode. I'm getting all... I don't need this. I already did it. That's what switch to output and switch to input are doing. And I think what we want to also do is value equals value. And this should set I'm getting all mixed up. This is the read. This is the write. It's doing a digital write. Do you think we can do a digital write before we set the mode? Like on our proper thing we can. And drive mode is just... right. Oh, ooh. What design pattern am I refactoring to? One I like better? I don't have a particular pattern that I'm doing. What I've found and what I've showed earlier is that, like, there's a socket object that calls a socket something function on another object and like trying to move that socket something thing into the socket object. Yeah, I don't know what the pattern is. I mean, Johnny called it rule of single responsibility, but I'm not great at the like terminology stuff. I don't know why this is dunder direction. Switch to output, self, switch to input. And then this is gonna go in there. That might give you a wrong result. What are you talking about, Charles? Sorry, the chat's so delayed that like having context is good. Yeah, if we set the value, I think that's what we want. And we can set drive mode directly too, as a way to just validate that they're not doing open drain, because open drain won't work. And let's do single underscore here as well. I don't know why some of these are single and some of these are double. I think that's right. I think that's right. Okay. Fixing code smell. Yeah. That's one way to see it. All right, here's what I want to do. I'm going to make a new file that I'm going to call pin.py. Yeah, I'll call it pin.py. I'm going to put this here. I'm going to delete all this stuff. Except what I'm going to do is I'm going to take this list, and I don't know why. So here's another heads up that you're creating, in this case, you're creating a list. So that's a big allocation. And then you're immediately making a set out of it. So it's a second allocation and the list gets thrown away. It's like another case of like, hey, just think about this. For number in this, I'm gonna make a, oh, can I do that? Can I set an attribute on a, if I can do the globals, but that's kind of gross. Or I could just hard code it. Because what I want to do is I want to have like IO 0 equals pin 0. And it doesn't need to know ESP. Like, it's just pin number. And this is trying to validate it, but I'm just going to say self number equals number. We don't have this reinitialization stuff. The representation. So Python has two different ways of producing a string. Repr is if you wanted to reinstantiate, what would you do? And then there's also string, and string would str. And I think, like, I don't actually want people to be able to construct these. Which, how do I do that? How do I prevent people How do I construct objects myself but not allow people to do that? I could make like a flag that says like, trust me. IO2 equals pin 2. See, I don't know how to do this at I don't know. IO4. Can't think of that. IO5 equals. David says, one of my favorite quotes from my coding bootcamp instructor is, friends don't let friends hard code. I mean, are you talking about what I'm doing right now? Because, like, there will only ever be these pins for this module. Like, I could write a loop. Like, I need to basically disable the init. Oh, I could do that. I could cheat it. So there's a like init done equals false. Yeah, I can't do it in a loop because I don't know how to put variables at the top level of a module. Sorry. Gonna do it the hard way. Probably doesn't apply in this case. Okay. You're being nice. I can see the spike in your brain right now as I write this list of things. Oh, I'm encroaching on Nina time, but I'm in the middle of it, and I think I wanna at least update the example as well. Keep typing the wrong thing. Hardware is hard-coded too. That's true. All right, let's see if I can't use some tricks that folks on the stream have given me. They're like, I have to like move my hand position, but then I can do that, and I can do that. And then I can do multi-cursor here to delete, and then just do 6, 7, 8, 9. All right, don't need this list. And then repr, I think we actually want to return, so we should return this name. I think we just want to return the string of ourselves for the representation because we don't want to tell people how to initialize us. And we should also say if init done, then raise a, what kind of error? Do you think runtime? Cannot initialize pins at runtime. And then at the bottom here, we just say init done. Block them out. All right. This is just a an ESP32 pin. Okay, the last thing I want to do is, yeah, my airlift's not working, but so there's Gpio examples. Let's look in here. Ooh boy. Keep in mind that these are 1000 kilohertz PWM signals using the ESP32 LED control peripheral, not true analog signals. As of Nina, you can read. You can also read analog signals using ESP on chip ADC1. I think this is probably... I feel like this is taken right out of the equivalent Arduino library. I'm going to ignore that. Let's update this. What is this? You may need to choose different pins for other targets. Reset all. Digital read. Digital write. I should have run this. I should have run this before I changed everything to see what its output was. I was expecting this to be like a simple example. This looks more like a test. Like while true. I mean, it's blinking every 5 seconds, I guess. All right, I think we should call it. I'm going to be doing a lot of this. But this library gets used enough, I think it's worth the time. And like I pointed out, there's other libraries that are modeled after it. So once we can switch this, we'll be able to, like, once I do this one, I can rope Brent into helping me switch the other ones over. And you know, redistributing all the logic across all the files so that they're more evenly distributed. So this has been a deep dive with Scott. I go by Tannewt online and now on WeChat as well. If you're in China, that's how you can get a hold of me. Thank you all for hopping in and hanging with me for this deep dive. I know that they're not always the most engaging, but I really appreciate it, and it sounds like people like it, so I'm gonna keep doing it. I think next week will be Friday again. My wife does get back on Wednesday, so there's a chance that maybe we'll do something. I try to post before I go to bed on Thursdays, so basically anytime on Friday you should be able to go on blog.adafruit.com and see a post from me about when I'm planning on doing it. It'll happen a day earlier if I plan on going on Thursday, so actually you should subscribe to the Adafruit blog. It's lots of good stuff. Adafruit is a open source hardware and software company that pays me to work on CircuitPython full time, so please support them. They're still getting rolling after COVID shut down the factory and stuff. So go to adafruit.com and buy some things. You can buy some gift certificates right now, and that will apply later when we have lots of really interesting ESP32-S2 devices. But right now you can buy airlifts. So the code that I was working on today is used on the airlift boards that we have. So check those out if you want to follow along. The wireless modules are actually, or the cell modules are really neat, and I'm actually I got some, so I'll have to try that as well. So yeah, keep an eye out. It's going to be probably a few weeks of doing at least a Wi-Fi for ESP32-S2, but people will be excited to see it. And yeah, you can follow me on GitHub, Twitter. I'm Tanu everywhere there. And I think that's about it. I hope everybody has a great weekend. And I'll see you next week. I should say, if you want to chat with me and a lot of other cool people all week long, you can go to the Adafruit Discord server, which you can go to the URL adafru.it/discord for that. And you can also join in our CircuitPython weekly meeting, which is our community meeting on Mondays at 11 a.m. Pacific, so 3 hours earlier than this stream usually starts. And that's just on the Discord. It's not broadcast everywhere, so check that out. And yeah, thank you all so much for hanging in there. Have a great weekend, and I'll talk to you next week.